from the studios of Postscript Media and Canary Media.
Last week, we brought you a couple interviews from our recent Transition AI event in Boston. And we started the show with a simple question. What do we want from the AI systems advancing so quickly? And inevitably, when we start grappling with that question, we have to talk about ethics. What do we want to avoid?
So an AI ethicist is one who is looking to prevent harmful risks to society.
This is Pamela Isom. She's the former director of the Artificial Intelligence and Technology Office at the U.S. Department of Energy. And she's the founder of ICE Advice and Consulting, which audits and advises on ethical use of AI. I spoke to her on stage at Transition AI.
So we're there to help ensure that your AI is going to perform as you intended, as well as understand how to de-risk the impacts of something that goes not so well.
There are two tracks to the ethics conversation emerging. There's existential risk and immediate risk. And people like Sam Altman, the CEO of OpenAI, are focused heavily on existential risk. This is like self-replicating AI that will minimize or maybe even attempt to destroy humanity, or an AI that can create and spread weapons of mass destruction or cause war because of a believable deepfake. Here's Sam Altman at a recent congressional hearing.
My worst fears are that we, the field, the technology, the industry, cause significant harm to the world. I think if this technology goes wrong, it can go quite wrong.
And then you have the more immediate risks. This is like lower-level disinformation that can swing elections, or fraud, or gender and racial bias.
Not just about harm, but equity.
The bias and inequity problem is very real now. Joy Balamwini, a computer scientist and activist at the MIT Media Lab, is focused on how this impacts AI training. And she built this immersive exhibit at London's Barbican Museum, showing how AI facial recognition systems don't recognize faces of color. Here she is explaining the exhibit.
I was a grad student at MIT working on a project that used face detection, and you saw it worked well on my friend's face. When it came to my face, it didn't work so well until I put on
the white mask on.
Yes, the white mask, right? And
then it worked perfectly.
AI algorithms reflect our biases, but more than reflect them, they will amplify them in dramatic ways. And many of the systems in existence today are being skewed by an oversampling of the kind of people who dominate Silicon Valley, white men.
So I call this pale male data. And if you have a lot of pale male data, you're destined to fail the rest of the world, who I call the undersampled majority, people and women of color, because they're not even included. And right now we have to make sure we prioritize inclusion and we prioritize ethics.
All of that gets built into those algorithms. So this is what equity is all about. Remove the bias.
When you think about deploying energy infrastructure, how could this potentially play out if you have bias baked into the system from the beginning?
So let's say we're looking at where to install charging stations. Aerial vehicles have surveyed an area, and based on what it has seen, computer visioning, the algorithm says, okay, we shouldn't put charging stations in this area because nobody's driving electric vehicles. Or if we're going to put charging stations in this area, let's not put the high-performing ones because I don't see anybody driving the real expensive EVs. And so communities get excluded.
From EV chargers to building retrofits to solar installations, AI can help target new opportunities for clean energy. But those systems are only as good as the data they use. And bad data could mean bad outcomes.
We don't want harms introduced into society. We got enough of that. We want to use AI to get rid of that.
This is The Carbon Copy. I'm Stephen Lacey. This week, two conversations about the ethics and implementation of AI, recorded at the Transition AI conference. We'll talk more with Pamela Isom about avoiding bad outcomes, and we'll hear from a group of experts about building AI systems on the grid. In both cases, it's all about quality of the data.
I'm Charles Dance, your narrator for Hindsight, a dramatized podcast from Al Jazeera. In this season, we hear from some of history's most notable women. An unconventional and extraordinary artist.
Me? I am Frida Kahlo.
A communist revolutionary.
Everyone in China knew my face.
You've heard of them. Now it's time you hear from them. Hindsight. Listen wherever you get your podcasts.
The Carbon Copy is supported by Fish Tank PR. In this turbulent and exciting energy transition, your approach to communicating with investors, partners, and customers also needs to evolve. Whether you need to position yourself as a thought leader in between project announcements or translate complex ideas and technologies into tangible, compelling content, Fish Tank can help. To learn more about Fish Tank's approach, visit Fish Tank PR. That's FISCH Tank PR. And if you're looking for your next role in PR or media relations, check out Fish Tank's open job listings on their careers page. The Carbon Copy is brought to you by SunGrow. For over 25 years, SunGrow has been delivering PV inverter solutions around the world, now in more than 150 countries. SunGrow's solutions include inverters for utility scale and commercial industrial solar and energy storage systems. Backed by a dynamic technical R&D team and an in-house testing center, SunGrow is committed to clean power for all. Learn more at us.sungrowpower.com. Pamela Isom is a software engineer by trade. She first got exposed to machine learning in the 80s, using it for production systems, manufacturing, retail, supply chain management. She's even deployed systems for wildfire prediction. So she has a technical familiarity with artificial intelligence, which she brings to her work on ethics. I sat down with her on stage to talk about what she calls the happy path for implementation.
So as a software engineer, when you are developing solutions, you're testing your own work initially, and you never want the software developer to test their own work because they see everything positively. Like, it's going to work. It's going to work. So did A do what it was supposed to do? Yes. Did B do what it was supposed to do? Yes. So you pass it because you kind of see what you want to see. But today, that's not good enough because the outcomes can be detrimental to society, can be harmful to society, and beneficial, as well as beneficial. So I got to keep the beneficial part in because it could be beneficial to society as well. So the happy path is saying, consider things don't go well. Consider the harms. Consider society.
What is the next step? If a company is saying, we want to avoid that problem, how do you then start to work on product development with those ethics in mind?
I work with organizations and pull together ethical frameworks. I usually don't start from scratch because there is material out there that we can reference, but I will meet organizations where they are, and we'll have a discussion on what are your goals, what are your intentions. And the ethical framework will consist of governance, cybersecurity, because there are, your data can get manipulated with whether there's bias integrated or not, and having discussions to help the organizations understand how what they are intending to do could be circumvented. I'll talk to them about the ethics team, how they should have an ethics team, ethics committee, or an ethics board, depending on the size of the organization, who should be reporting to and what instances should be elevated to the director level versus what issues can be handled at the individual level, and how to go about ensuring, too, that in these situations that you have good recovery and continuity plans in place. So those are examples of the conversations I have and the conversations that we should be having.
So the companies in this room are at the front lines of figuring out this happy path, but the regulators need to come in and follow, and they're way behind the acceleration of technology. And so, you ran the Artificial Intelligence Office at the Department of Energy. I know that there are some limitations on what you can specifically talk about, but I think there's this big question about how lawmakers and regulators and agencies are trying to figure this out, whether they are explicitly grappling with inequities or they are talking about some of these bigger existential risks. There is this huge question about what kind of regulation we need to see. And so I wonder what your thinking is on where the government is on trying to figure this out and what needs to happen?
I like what the government has done around the AI risk management framework.
What is the AI risk management framework? What is that?
It has a set of scenarios, and it does go into some of the type of risks that one may experience and how to go about addressing them. It talks about the different types of biases, and how you want to, whether you or not you want to include third-party testers, for instance, as a part of your verification and validation of your solutions. It's a pretty good comprehensive product that was developed with input from industry and academia. So it's there as a reference guide. It's not a prescription, but it is a reference guide that I think is helpful. I have the opportunity as a part of the AI and Technology Office to participate in the AI Bill of Rights, which is good as well. It kind of talks about some of the things that I've talked about here. None of them really provide step-by-step guidance, but it does give you a sense of what to watch out for, and things that if regulations are to come, they would build on top of it. So I think the U.S. government has done a pretty good job, but we're a little bit behind some of the other countries like Europe.
And just a little bit behind the industry.
I'm just going to say a little bit, and I'm going to say that's my opinion.
So your career has, you've used AI for industrial efficiency, for infrastructure, for what you didn't mention, for wildfire management and prediction. So you've seen all these positive outcomes. Do you consider yourself optimistic about the future of this industry?
I do. You can mitigate the risk, get ahead of it, get your auditors. I am very optimistic about it because we cannot process all this sensor data ourselves with accuracy. But we can teach our AI and train our AI to process with accuracy.
Pamela Isom, thank you so much.
Thank you.
We live in a world where the news is at our fingertips, where we're one click or swipe away from the latest headlines. But how often do we stop swiping and scrolling and just listen? It's the difference between knowing what's in the headlines and understanding how it got there. I'm Malika Bilal, and this is The Take, Al Jazeera's daily news podcast, where we bring you the context and the people behind the global stories that matter. Subscribe wherever you listen to podcasts.
The Carbon Copy is supported by Fish Tank PR, a media relations, strategic messaging, thought leadership, and social media agency dedicated to elevating the work of early-stage and established companies that are solving some of the world's most pressing climate and energy challenges. Clean tech is noisier and more competitive than ever, and despite the opportunities that the Inflation Reduction Act brings, complexities and roadblocks abound. The Fish Tank team has been in the industry for a decade and takes a comprehensive and creative approach to communications no matter the market's ups and downs. To learn more about Fish Tank's approach to clean tech and the services they offer, visit fishtankpr.com. That's fish, F-I-S-C-H, Tank PR, or go to the link in the show notes. And if you're looking for your next role, check out Fish Tank's job openings on their careers page. Support for the Carbon Copy comes from SunGrow. For over a quarter century, SunGrow has been providing reliable and cost-effective solutions for the solar industry. SunGrow inverters provide efficient and reliable power generation to maximize your return. With SunGrow's expansive product line, you can trust that your system will perform at its best day in, day out. Not only has Bloomberg New Energy Finance rated them as the world's most bankable inverter, but 40% of SunGrow's employees are dedicated to R&D, ensuring that products are always at the forefront of the industry. SunGrow has over 340 gigawatts installed globally across 150 countries. From utility scale and C&I solutions to energy storage, SunGrow is committed to providing clean power for all. Learn more at us.sungrowpower.com. So we know why, at an ethical level, it's so important to have good data. It's also extremely critical at an operational level. And that sounds pretty obvious, but I always find it surprising just how limited good data is on the electric grid, for example. Lots of data exists, it's just not shared in helpful ways, or it's not formatted in a way that can be used. And that brings us to our conversation on the use of AI for utility operations. David Groarke, managing partner at Indigo Advisory Group, has cataloged the different AI applications on the grid, and they are widespread.
It's worth billions. There's 50 plus use cases, depending on how you define a use case. There's hundreds of vendors in this space, from startups to conglomerates, the existing grid giants, Siemens, Schneider Electric, GE, etc. And there's use cases that have been deployed for many years around energy forecasting. And there's capabilities that utilities are quite comfortable with. So there is this market.
And David took the stage with a group of people figuring out how to define and grow the market for automated intelligence in the electricity business. It included Elizabeth Cook, the Director of Advanced Grid Systems at Duquesne Light Company.
So I originally came from power system engineering consulting for the first 12 years of my career, and I've been at Duquesne Light for the last 7. I'm a data nerd. I've been building models, grooming data, and running analytics my whole career within the utility space.
Titiaan Palazzi, head of power utilities at Snowflake. Titiaan co-founded Mist AI, a startup focused on precision forecasting for supply, demand, and market prices.
Earlier this year, Snowflake, which is a large cloud data company, acquired Mist to accelerate their AI functionality. So now I get to see, from the purview of Snowflake is 7,000 people publicly traded in the US, from the purview of a much larger organization, what that looks like, expanding not much beyond a single AI application into basically all of them.
And Jess Melanson, the Chief Operating Officer of Utilidata, which makes an AI-enabled smart grid chip and software platform in partnership with the leading chip maker, NVIDIA.
Most other industries that have adopted AI have a mix. So in warehouses and factories and farms and the navigation on your phone, there's a mix of distributed and central AI. And so nobody's really done that yet in the utility space, created a native AI platform for the edge of the grid. And so that's what we're doing in partnership with NVIDIA.
The 4 of them went very deep on where AI can be helpful right now, and why the limitations aren't the power of the systems, rather it's the availability and quality of underlying data.
For you, for Duquesne, what does AI mean to the landscape of the utility right now? How are you defining it?
So I would say that I'm careful on throwing the word AI and artificial intelligence within. It's really I see this as a people issue within the utility space. Our bread and butter is to keep the lights on 24/7, 365, and we've been doing it for over 100 years. So, what is the need for all of this additional sensoring and measuring? And it's really creating and crafting the stories around how we can use data to make us better, more effective in being safe, reliable, and now on top of that, of course, affordable, but resilient and sustainable. So when working with the data, it's really just starting to build it from the ground up and educating all of the different. So I come from system planning, which is like the stem of how we actually plan and prepare the grid, and then working in parallel with asset management to really understand the health and the utilization of the existing grid and start to create that conversation to empower us to bring insights that we have not had before. So really saying everything about AI, but without saying AI, if that makes sense. So we have done a lot of cool use cases within, and we're building on that. And I would like to say, that roadmap that you showed, in 2017-18, I started harping on the importance of using our AMI infrastructure that we rolled out fully in 2018. When we had all of the meters, can we start gathering that data? And very quickly I realized, we were mandated or regulated, right, to install these new meters to really make us have a very fine-tuned billing machine. And I think that's happened across the whole industry. But very quickly, it was like, well, there's very valuable voltage data and current and VARs. And I got significant pushback. What would you need that for? So it really sent me on a trajectory of educating not only my group, but I stood up an Electric Utility 101 course module where I was teaching all directors, executives, all the way through to our customer care, to our legal counsel, to say this is why we need this data. And it started really early in 2018. So that really put me on road mapping the grid modernization plan. So the slide you have is really something I speak to on a daily basis across Duquesne Light and really anyone that'll listen, that we are, if we do this right, no regrets in regards to it will make us better at what we should be doing today, which is serving safe, reliable, affordable power. I can dive into the use cases as we talk, but really installing the infrastructure to gather the data, to really bring it back to the mothership, which requires a lot of data to do so. So can we do it at the edge? So we are partnering with Utilidata to kind of experiment with that and really start to gravitate and share and communicate within all of the utility of how this data can really empower each individual group.
Yeah, and I love that idea of being able to tell stories, right, around data. Titiaan, a similar question. What does AI mean to landscape right now for you from where you're sitting in Snowflake?
Well, I think that it seems that we're already picking up on maybe one takeaway from this panel, which is that it's all about the data.
Right.
Which, Jess, I hope that I think that you would agree with that. And Liz, you just said so much. So I think that, and maybe to tease that apart, that applies in many different places. So part of it is grid data. It can be data from transformers, substations. It can be data from generating assets. It can be data from homes. Another world that applies, maybe less to Duquesne, but to integrated utilities or to other players in electricity markets, is the market data. So getting data from there. It's actually quite interesting. I remember on our team at MIST, which was mostly an engineering team and data science, that a lot of the time to build AI/ML models was actually spent in getting all the data in the right place. So for instance, if you are trying to if you're a renewable supplier and you're trying to see how much wind power you have available and decide whether to sell that in day-ahead or real-time markets, so you're doing renewable supply forecasting and market price forecasting, a lot of the work of doing that well is actually figuring out, what's the temperature going to be tomorrow in different zones? Where are there outages from generators and transmission lines? What do we think the net load ramp is going to be? So a lot of the work in this specific use case, price or renewable supply forecasting, is in getting all the right data. And that it might be data from your own assets or your things that you know, or it might be data that come from partners. So you might have data vendors who you source that data from. I see AI in different places at the asset level, so grid level. I think that the two of you are speaking mostly about that, but also at the customer side level and also at the market level.
Okay. I'll just share, when we think of the power grid, right, I think we have to make sure we're differentiating. We have the bulk generation, right? So, and how that responds and what it does is actually incredibly intelligent and very self-protective, right? I mean, their job is to maintain their $1 billion piece of equipment continues to spin 60 hertz, the frequency stability, rotary angle stability, and we have a ton of analytics built into those systems. So not that if I'm not worried about those generators, because our transmission grid does connect with bulk generation. The next level is transmission. I think the T and D, we really need to stop talking about them together. They're very different organisms in themselves. Transmission is 3-phase, balanced power flow that requires a very different set of equations to run those analytics. And we're really tied to really computational systems that were built in the 70s by some generator experts that really built out these power flow equations and started running these analytics. So how we revolutionize and really unlock our transmission interconnection queue really comes down to really getting into those models, being more intelligent with the data that we do have, and doing a whole different set of machine learning. And then comes the distribution system, which I think we haven't untapped the power and the capability it will have, especially with the distributed energy resources, which comes the markets. So I would say, being a T&D, you still have this functionality that you need to be worried about all. And then lastly is the customer. The future vision is each building will become an asset to the grid to perform so that we can continue to serve electricity to all. So if we're not looking at the microcosm of how a building will now become a dynamic virtual power plant or a dynamic generation, right? We're missing the big picture in regards to how do we bring all four of those entities together and really correlate and work together. So in regards to the de-siloing, we have to silo because they're all different, but then also look at it holistically so that we're able to unlock potential in one versus the other and they can communicate together. So I just want to say, like, even being a T&D, like, we're really thinking about in the end game is everyone wants to tie dollars to those electron flows. So how we do that, there's a lot of work ahead of us, but I think it's there. The technology's there.
Yeah, and in terms of, that's a great description of the system, and it gets less smart, and there's less data, and there's less control the farther you go down to the end, which makes sense because historically, the action and the money and the competition was at the bulk part of the system. And so the last mile was sort of the sleepy last mile infrastructure. That's about to invert, where you have all this activity, you have mobile batteries, you have engaged customers, you have all this technology in the home, and the utility is sitting there with the least amount of data, the least amount of information, and virtually no AI, certainly AI that runs real time or on the physical infrastructure. And so that's why we focused on that part of the grid. And there are definitely folks who say, that's why start there, and is that too much horsepower? And we would say, definitely start there. And the one thing you should not underinvest in 2023 is data capture and computational horsepower, because it is, while it may seem expensive in a narrow lens of the investment, it's going to be what saves you money time and time again as you build new software applications. And so Utilidata started as a software company. We were a user of grid data. We have a voltage optimization product. And so we tried to use grid data in operations and in real time and realized the limitations. It was slow, it was incomplete, it was misleading. And so we spent all of our smarts trying to fill in gaps in information, trying to infer what's happening. And so the point of these investments at the edge is that you don't have to guess what's happening. You can spend your time predicting what will happen next or figuring out how to react to what's happening. And so that is a shift that would get the utility. I mean, Amazon isn't guessing what's in their warehouses. They're figuring out how to get it out to you cheaper, faster, better. And so the utility with the right technology investment and the right data can start to make that shift.
That's a great point. So let's just talk about that for a second. The data availability, the data quality, the utility. Let's say from a vendor perspective, are you seeing various maturities across the industry? And from a utility perspective, is your data great? What needs to be done? How long is this going to take to kind of get the dog fit for the fight?
On the distribution grid, there are some investments in there are progressive investments in sensors on the distribution grid. And again, I think it's more at the substation and less as you go down. At the very edge of the grid, the data is usually late and sparse and hard to reconfigure and reprogram. And so it's been pretty low data, which is why we sort of went into this platform world. I was talking with Mike Phillips from Sense earlier, and both of our companies are happiest when writing algorithms and developing software, but we had to go to the source and create the data source and create the platforms to actually do more. So I would say it's pretty uniform because most utilities have gone through these grid mod processes. In your presentation, they went through that phase of sensors and basic grid data, but it's a inadequate bar for where we're going. So we need to now take the next step in investing. And that's not 10% more data capture or processing power. That is orders of magnitude more data and processing power.
Yeah, so maybe for context, Snowflake, the company I work for, is a cloud data warehouse, and we have hundreds of power utilities clients. 5 of the top 10 US IOUs store their data on Snowflake. And that's data from CRMs, but it's also data from AMI meters. So I think I have a reasonable purview in the answer, like the complexity. I think everything, Jess, I would say everything what you said. One of the things that I'm most excited about in sort of like thinking about contribution to energy transition that enables AI is in a world in which you have power generators, utilities that operate transmission and distribution, customers, a variety of DER providers, aggregators, so at least 6 or 7 different players who actually need each other's data to do interesting things. Can you make sure that that data is available to them? So to make that a bit more visceral, could a company that bids in demand flexibility from residential customers pair with General Motors, who has EV charging, and SunPower that installs solar panels, so that jointly they co-optimize the home and they share data with each other to know which customer is the best fit for solar panels who don't have it yet. And so I think that one part of the data quality question is how can you ensure that it is shared across the stakeholders in a manner that is compliant with, personally identifiable information.
And can I one more vendor
Please,
point?
yeah.
One more vendor point before we get to Liz. That it's a hugely important point. If you have a sensor company and they say we're going to upsell you your own data, that's a problem. If they say that data is not going to be interoperable with your other systems, that's a tremendous limitation. So we're building an open platform with tons of computational space for anyone to build, multiple people to develop AI models, third parties, utilities, DER companies, obviously with the utilities, security, and kind of gateway in mind. But that's a shift. And if you don't open up the data to everybody and all the providers and all the systems in the utility, then you're going to keep having these stuck silos that have capped value.
From a utility perspective, how would you like to react?
So just a little perspective, I'm also a part of the AEIC, which is associated as an illuminating company. It's the oldest electric utility member organization, started by Thomas Edison, 1887. So it's 185 utility members, and I'm the chair of the Distributed Energy Resource Subcommittee. So we have active 30 utilities that I get to work with and network. So one cool thing about the utility space, even though that's very rarely said in the same sentence, is we love to share our lessons learned. We love to share what we're doing because we can, and we're not really truly competing with each other. So I guess I'm speaking from that perspective of really interviewing and being a part of that network. Our data maturity level is sparse and in between, right? So there's some of us that have been forced and mandated to roll out and really adopt and change quickly, and then there's others that are really looking at it and looking over our shoulder and learning and really starting to implement those messages so that we're prepared for that reality. So depending on what data we're talking about, from a transmission perspective, we need to know the ins and outs because in the 1970s and 80s, we chose as an industry to start interconnecting with each other. And then that required, the federal regulatory realm to really start and really what are you doing? What does your data look like? Is it accurate? And there's a whole bunch of standards that we are really required to maintain. And I'll just say, when I was interviewed to be the senior manager of transmission planning, I would not have been a utility member if they told me about what compliance means. It's a huge burden to a utility space. I mean, it's needed, but the amount of overhead to ensure that the data is accurate, correct, and that we're feeding these models so that we can run the 24/7, 365 power flow solutions, not only in our own operation centers, but all of our RTO ISOs, is a huge lift. So, I mean, right there is a realm for where AI could help our industry if we just allow it. And that really becomes a people thing and really that regulatory hierarchy of not understanding the powers of be and being more fearful and resisting change. So there's a human aspect to all of us adopting AI into the electric utility space. So I would say the data for transmission is quite good. And when you talked about PMUs, there was some funding for us to roll out PMUs, and we would all embrace. It's very important. Our models do not sometimes represent actual field events, especially with FIDVR. I haven't said that in a while. Fault-induced delayed voltage recovery. We really can't replicate it from a transmission perspective holistically. And there's a lot of other things that we can't replicate, but we keep moving through. The lights stay on. So. But the maturity is solid. PMUs would really help, but a lot of we have 2 in our system, and I'm looking for ways to use them. But that was a requirement. So I think if it came from a different perspective and you had a different creative mind thinking of how this could open a window and create models, that would be better champion. But I'll say, being an R&D agent, being a change agent with a utility that's regulated from the federal and the state, sometimes you're beaten down and really you're not really inspired to keep on going. For the distribution system, it's a whole ballgame, right? We're state regulated. We don't have those mandatory requirements to have these robust models built, and a lot of us are quickly building those models. We just, goosebumps talking about it, we did a whole LiDAR of a distribution system and uploaded 7 million points, and now we have an asset-associated database in GIS, which means we have a whole distribution system modeled in GIS. Our next step is making those models power flow models. We have about 63% of our system. So if you look at the breadth of all the utilities, there's some utilities that they've had their whole system modeled for a while, and they're running DMS and Flizzr and doing all that fancy AI. I love that we can call Flizzr AI, but there are utilities doing that. But then there's all a bunch of utilities in between that really haven't been driven or seen a need, because we've literally, as an industry, said it's the distributed energy resources that are going to drive you to want to build these models. So we really got to pivot that language as you actually can become a better utility more effectively and efficient with everything you do, from your capital work stack to your OMN planning, if you had your models built and you ran and understood how your system was performing. And so that message, I think, needs to get across to all utilities to really embrace the power of building those models. Now, I would say 10 years ago, there's probably like 10%. I think we're probably maybe up to 30% of the systems that are fully built in the distribution. And then lastly is your customer data. This is data that we would really love to have access to so that we can help serve and provide value to the customers that yet maybe they don't even know they realize. Mm-hmm. But the utility is who that we are, how we came to be. We could all sit here and debate. Nobody really wants the utility to have this data. And so how dare you talk about creating algorithms to identify where an EV is. You have to be careful with how you say that when you say that, because that maybe someone doesn't want you to know you have an EV. But we also need to change the message to our customers that if you start installing charging across all of our grid and do not inform the grid, we never mandated you to tell us about your heat pumps or your poles or your spas. But I'll tell you, if Mr. Jones and Mrs. Smith and all that neighborhood installs all of those gadgets and gizmos, their transformer will pop. So this phenomena hasn't been missing, but we need to know what that data is, right? And why we need to know is so that we can ensure we can serve you, who's choosing this new technology, and then we can ensure that the others that have not yet, and maybe will not, unless mandated, because at one time not everyone had a furnace, we need to be able to serve each individual home as a public utility. So it's really that balance and that storytelling to ensure that people understand that why we want the data. It goes all the way from the customer to the bulk electric grid. If we can untap and really utilize the existing assets that we have today and then transform, is really where we can make a difference. So maturity level, it's all over. But there's a path.
That's a great representation. It's complex. It's very situational dependent on where it sits in the value chain. And you mentioned, Elizabeth, this idea of stories. That's important even to customers or within a utility or to a regulator around data. I want to maybe dig into some of those stories. And perhaps, Titiaan, we'll start with you in the middle. Do you have any favorite stories about AI in the utility sector right now? Maybe it's from a power markets perspective from where you sit. But I'd like to be able to kind of demonstrate to the audience the potential of AI in a real-world use case in a utility environment.
Sure. I can share one. So maybe some context. In California, basically, most of the grid is run by 3 large utilities: SDG&E, SCE, and PG&E. But in California, and there's no retail competition. However, you have this thing called community choice aggregators, which are load-serving entities that manage the customer relationship, but the power, the electron, still goes through the grid managed by the 3 large utilities. And one of the things that was happening during the heat waves was that electricity demand was going to levels that it had never been before. So you basically saw peak load in California. And this is the story of our days. I mean, even right now in Texas, we're seeing peak loads. So what was very interesting to see was the level of data access, smart meter data access, that some of these CCAs, the community choice agencies, had varied greatly. So during the event, the California ISO, the system operator, as well as the PUC, the Public Utilities Commissions, were having a hard time actually understanding what the expected demand was going to be. And that made operating the grid to ensure there was enough reliability and there wouldn't be blackouts was very hard. So there was a kind of uncertainty of many gigawatts, 5-6 gigawatts, of how much would actually be needed. So that's dozens of smaller scale power plants that you need there. But the part where AI helped was some of the CCAs had good AMI, so smart meter data. And by aggregating that data, as well as different weather data, we were able to reduce some of the load forecast error by more than 50% compared to other CCAs who didn't have that. So that helped those individual organizations. But if you extrapolate that, it also helps the grid reliability. Because if you can do this structurally, use the best data to improve your forecast, you now actually have a much higher likelihood of avoiding blackouts with the same physical infrastructure.
That's a great story and great results, and plays to the importance of data quality. Jess, what about stories from your end?
Yeah, actually a very similar use case, but from a different perspective. So there's a lot of people sort of gravitate toward the fancier stories about analyzing waveform data and finding equipment faults and predicting fires and co-optimizing hundreds of thousands of DERs at the same time, all of which are real and have a lot of promise. But I like sort of grounding it in simpler things like demand forecasting. And so when you put our product, which is called a smart grid chip, at a premise, it has some embedded AI models that start learning right away, predicting the demand of that home or business 24/7, 365, and learning when it gets things right, when it gets things wrong, input weather data, getting smarter about how it predicts it, et cetera. And similar algorithms for detecting and predicting the behavior of big loads like EVs or heat pumps. I'm sorry, Liz, we do know where your EVs are and when they're charging.
I know you do.
So when you think about that sort of a capability, what does that do for a utility what does that change in a utility on day one? Probably not very much, because everything they do is built around not having that information. Their processes, their systems, their people never expected to have that information. So this is sort of the paradox with AI. It's hard, that the business case for premise level load forecasting today is a little speculative. But if you had that at every home, at every neighborhood, feeder, substation, system, it would totally transform every way that the utility does business, how they plan and build their grid, how they buy supply, how they execute flexible demand, the rates they charge their customers, the programs they offer to their customers. And so something simple, and by the way, you can host lots of different load forecasting apps and see which one you like best, but something simple like a learning model that is getting better and better at predicting this premise level demand can start small and then end up transforming the whole way the utility does business.
Stories, Elizabeth, from you. I'm sure you've got a few from Duquesne.
Yeah, can I share a few?
Yeah.
I'll just, the one being transmission was my first love. I ultimately tapped into grid enhancing technologies. One thing I did for the first 12 years was build models based on data, and ratings were the pivotal value. And a lot of rework happened when maybe a fat finger in a database that I was given that I would not know about was changed. But that rating is the rating of your transmission facilities, right? Most specifically, the conductor. So grid enhancing technology is one of the ones that we have installed is the dynamic line rating with line vision. And so ultimately, we put it on 3 of our facilities right now, and we're looking to expand upon that. Not our whole system, but really to start to fundamentally understand what are those dynamic variables so that we can start looking at how we rate our assets. And I'll just say, there's a huge conversation happening around GETS and how it could potentially unlock, our queues of generation. And it has a lot of use cases. But from Duquesne Light being a transmission grid that was built to serve a steel industry that is no longer, we're kind of like a microcosm in itself. Yes, we're tied to another grid, but like our flows and what we do, is kind of understood. But if we can show and prove out that data can teach us something and give us insight to really drive the conversation for the larger industry, really creates value in itself. Can you put monetary dollars onto that? No. So it's really creating that business case around, market congestion or asset management awareness. Like you can determine if there's icing on your transmission facilities that you have never had. And so I'll just say, driving that new type of technology through a utility that wasn't mandated, it requires a certain amount of effort and approach of how you. But from those learnings, what I realized is if you can do things quickly and swiftly and to create value and start communicating it is your best bet. So I ultimately with these efforts is when I was tapped and got the role that I have now, which is advanced grid systems and setting up the roadmap for grid mod and create a team around me, is tapping into data that doesn't require significant lift, aka internal investment, and working with partnerships. So the first one was I wanted to prioritize our 4 kV elimination plan. We have 4 kV, which is an obsolete distribution voltage. When we go into the capital planning process and they ask us why, I wanted concrete analytics to not only say it's overutilized and the peak loading in X year, but who are we impacting and where in our geographical space has a more risk. So I partnered with an organization called Urban Footprint, where we pulled in our data as well as a significant amount of external data and started layering that information, really speaking to that prioritization to drive our grid resiliency index, which then creates a concrete story to go talk with, how we plan our capital. That was one fun use case. And it was really, just using some of the data that I've been hoarding for the 7 years and providing that, as needed. The other use case was we didn't have system topology, and it was actually part of my dissertation work, and I wanted that voltage data from the smart meter data. It took 4 years, but that's a whole other story. But once I received that data, I ultimately did my dissertation on it, and it caught the eye of a company called Utilidata, who they had an algorithm architect, who really said, I want to take this work and really grow it. So he, and with the collaboration of his whole team, successfully rolled out our secondary topology identification of our meter-to-meter transformers across all 600,000 meters. That is super exciting. None of you are geeked out and excited, so I guess you don't mean. No, not many utilities have their secondary modeled. Not many utilities know exactly which customers are connected to which transformer and which transformer is connected to which circuit and which circuit is connected to which substation. I know that seems crazy, but it's true. So that was a huge successful story. And then I'll share the last one, which is kind of fun. It was, again, in my advanced grid systems group, taking the data, listening to the data scientists. We partnered with a group called eSource. They've created a couple stories, but the one that I just saw, go live is a storm prediction. So really taking all of our historical outage data, which is human input, which can be better, but is quite dirty, didn't stop us, and providing that to them, as well as all of vegetation maintenance records, and then they pulled the external data of all of the weather. And so created an awesome dashboard. So when storms are rolling through, it really will light up 5 days, 1 day, 10 hours, and then up to an hour, and show us which service territories will be hit with which or what number of outages, so that we can dispatch our crews, we can start communicating to our customers, and really we have more insight to what may happen, and that predictability, and really that it's, artificial intelligence, because it's only going to get more intelligent with what we've created. And so the last 2 storms have predicted it pretty spot on. So that's an exciting use case story, but it was very but really shows value. And then you share that with your members, and that's when they start, wanting more.
Excellent. Yeah, they're great examples. And I think they maybe bring this to life a little bit more, in that there's current problems being solved by AI right now in the utility sector. Particularly around some innovations in grid enhancing technologies and so on. If we look to the future, and we had the slide that had the kind of futuristic sense in there, are you optimistic about AI over the short or long term? How would you assess it from its potential? Back to you. Yeah.
So, I believe, obstacles, they do not block the path, they are the path. But I'm learning very quickly that, my obstacles are really that storytelling and communicating the benefits to our customers, and therefore our regulators, and therefore our ownership, of how we should continuously invest in these technologies. And, really the idea of what technologies are we talking about? It's the sensoring and the measurement, right? So having the ability to gather the data. It's also, what is our strategy around our communication, that bandwidth, right? How do we bring all the data back? And what data do we need to put back? And at what latency and what frequency? There is an end game where if we did grid edge, distributed intelligence, with these smart grid chips, that could reduce the amount of data. So really that whole package of that amount of data, because it will be costly to our customers if we don't bring that curve down in regards to how much we pay to bring data across the networks. So that's a huge part. But, how to create that awareness that, as Jess said, we don't do certain things and we've never had this data. So to build use cases and then create business cases that drive deferment or cost savings, cost avoidance, or revenue, is a lot of, there's no concrete examples in your own utility to then prove it. So really having that craft to show that viability. And so you have to use your industry benchmarking to bring that intelligence in and then create that business case to show the value that you're driving for your customers. So that's, when I think about getting to the peak of your roadmap, the end game to me is energy transactive markets, right? Which, a T&D company really doesn't think about, but we are the facilitators of those electrons. No matter how we show up in whatever market is created, we'll need to be able to ensure that we can operate the grid through that transactive exchange, a monetary value that we are going to put on these electrons. So really, we must do that to be able to create this reality. So from a hopefulness is if we do it right and we drive those values and really gain that benefit conversation with this is how we're benefiting the customer, and really believing that this is the reality that we're going to sit in, we can really make and untap again that what we need to do to transform the whole net zero conversation. So
that makes sense, Jess.
Yeah, and the business case is the hardest part. Selling distributed AI to utilities is harder than actually executing the AI, because and everybody who sells and works with utilities knows that their historic incentives are not pro-innovation, not pro-software, not pro-future-proofing investments. And so we're going against all those headwinds when we try and make a case for this. But so if Liz wants to make a grid mod investment, she goes to a regulator and says, I have a widget, it costs $100, it drives $120 of proven benefit. I know it, we've done it for years. And the regulator says, can you do it for 90? I'm going to make sure you get that 120, and that's it. So that's great, you made an improvement, but that's a sort of a limited investment. And so what you end up doing is stacking a lot of hardware-defined limited investments on top of each other, and you end up with a grid that's not modernizing quick enough. It's expensive because ultimately in the bigger picture, that's a more expensive way to do things than to generate a software update. But we have to get past that. And so part of what we're doing to get past that is we need our anchor use cases. We need the use cases that justify the cost of all that data capture and software and processing. And we have candidates that we're proving out now around DER integration and real-time visibility, deferring some asset upgrades. And so you can sort of justify this investment, but then you have to resist the urge to skinny it down to just do those things, because then you're stuck in the same loop again. You have to actually make sure you invest in that full data capture and processing at the edge. Federal funding helps. It's perfect for spurring this kind of a thing, and we're going after some of that. And then you have to engage stakeholders at every step. And we have a great team that does that, and we're very focused on engaging consumer advocates and telling stories about what does it mean to customers, environmentalists, making them understand how this will be an impediment to reaching their goals if we don't modernize this part of the grid. And then probably biggest of all is within the utility. You have to convince 100 people, not one. And so, there's a lot of sort of selling and trying to explain to people why this will actually make your life a lot easier. This will make what you do so much better. But there's a resistance to it and there's a reluctance about it. And so we have to overcome those hurdles. But once we do, I think it's going to really be an exponential change, because this will just become the industry standard and the paradigm will shift, and then everyone will say, well, why would I put an asset out on the grid that's not AI ready and smart? It'll become a non-starter. And so we just have to get over that hurdle.
Optimistic. Titiaan, do you agree? Are you optimistic? Do you agree with Jess in terms of the future?
Yes, I would also say, side note, Jess, you have Liz, you have amazing one-liners. Transmission was my first love. Obstacles don't block the path; they are the path. I think we should have a philosophy white paper coming.
I've been writing them down.
I'm totally optimistic. Yeah. And I think also some of the stuff that we said is hard. I think can actually. So I'm not sure about selling yet, but maybe. But data collection, AI might be able to help. So I'll give you another one. I think one reason why actually people who sit in the business line, so let's say that you have somebody who's on your grid planning team, it's quite possible that maybe those people have deep utility expertise but are not particularly proficient in writing SQL or writing Python code. But now, I don't know if any of you who are not coders have tried, but it's crazy how easily you can transfer natural language to code. Especially SQL, you can basically say, I would like to have the voltage for the last year, 5-minute granularity for these substations. And if you have the right chunks configured, it will give it to you. So I that's another reason why I'm optimistic.
Yeah, I just had, workforce, right? Like who we recruit. I think a big part of getting to the top is creating the awareness that the utility space is innovative, creative, and if you change the utility, you change the world. But
Number
because
7.
we are like the hindrance, right? So, but if we can gain the talent, and so I was having a really hard time getting this one group to do one thing, and I just didn't have the time to pull out my own Mac, and so I hired a new employee. I floated it by. He knew Python, and within one day, he extracted this data that I've been looking for like 9 months. So really finding that key talent that has some really, let me get dirty with the data and create that, code and just start churning out and really creating value that is, not really available in the recruitment status, right? So I think also having the message that the utility space is changing. And so how do we bring that talent inside? So we do need our electrical engineers, but we also need our data engineers, our software engineers, and really changing the table of like our IT relationship with operations is a huge deal.
And that's going to do it for the show. Thanks for listening. If you like the themes and conversations that we're featuring from the Transition AI event and you want to attend, we're going to have another one in October in New York, so stay tuned for that. Thanks to Canary Media for being our partner on these pods. The Carbon Copy is a co-production of Postscript Media and Canary Media. This episode was produced by me and Sean Marquand. Roy Campanella Jr. mixed this show, and Sean Marquand came up with the theme music. Other original music came from Echo Finch and Blue Dot Sessions and Epidemic Sounds. Postscript Media is supported by Prelude Ventures, a venture capital firm that partners with entrepreneurs across energy, food and ag, transportation, logistics, advanced materials, manufacturing, and advanced computing. Give us a rating and review on Apple or Spotify and send us your thoughts on social media. And as always, we appreciate you being with us, and we will catch you next time. I'm Stephen Lacey. This is The Carbon Copy.